Hi, we're going to take a quick look at probability tables and tree diagrams. Okay, so let's get started. First things first, we'll look at probabilities and frequency tables. For this, you have two key rules to remember. Go for them one at a time. The first one is that probabilities always add up to 1. So if we look here, we have a missing probability for the odds of Jeff winning a game. The way we're going to work it out is we're going to add up the other 3 people and then work out what's missing to give us a total probability of 1. So let's do that now. If we add up these 3 people, and we have a calculator for this, so 0.34 plus 0.4 plus 0.16, that gives us 9/10, or as a decimal, 0.9. However, because probabilities must always add up to 1, that means the odds of Jeff winning is going to be 0.1. Okay. Then reading the rest of the question, they play a total of 50 games. We're going to work out an estimate for the total number of times Jeff wins. So the odds of Jeff winning is 0.1, and he's playing 50 games. That takes us to rule 2. To work out an estimate, you are going to have the total number of games, and then you're going to multiply it by the odds of him winning. So again, this is an estimate, it's not guaranteed, but it tells us what we'd expect to find out. So in this case, we play 50 games. The odds of him winning is 0.1. So overall, we'd expect him to win 5 games. And again, don't forget you have a calculator here to do that maths for you. Okay, that's the first half. You have some questions to try. I won't zoom in on them, but there is a link to all questions in the video description. You can look through there. And we're going to look now at tree diagrams. Okay, so a tree diagram is basically a way of displaying data. These seem to come up every year in GCSEs, so make sure it's a topic you practice on and you take the time to keep practicing it until you are confident with how it works and all the ins and outs of them. Okay, I've got 2 examples to go through. First one, the odds of Claire winning the game with Paul is 0.4, and that's fixed. That's not going to change throughout the question, and we'll see in a bit that that's not always true. Then she plays 2 games. I'm going to work out the odds of her winning exactly 1 game. Okay. So before we get started, before we actually draw the tree diagram, it can be useful to list the ways she can win exactly 1 game. So we basically have 2 options. She can win and then she can lose, or she can lose and then she can win. What we're going to have to do, we're going to have to work out both these separately and then add them together, because either one of them could happen. So let's draw my tree diagram. They're basically a way of displaying all possibilities from a certain event. This one's quite short because there's only 2 possible outcomes. She can either win or she can lose. As far as we're told, there's no way she can draw. If there was, we would need a 3rd branch here, but we don't, so we need 2 branches. We then want to write in those probabilities, so 0.4, and again, recording that probability is always add up to 1. That means this must be 0.6. That was for her first game. We then have the second game, and these are going to sprout new branches at the end of the first branches. So what I mean, I'm going to have another win and lose here, and another win and lose here. And like I said, these are going to have the exact same probabilities. And if she played a 3rd game, we would then have branches off all those 4 options, and so on and so forth. So just to explain it, this displays all options we've got. So this path here represents winning both games, this path here represents losing and then winning, and so on and so forth. What we need to do now is work out these probabilities. To do that, the key rule is you always times along the branches. So I want to work out win then lose and lose then win. So win then lose is this path. To work out the odds of that happening, you do 0.4 times 0.6. You always times along the branches. We also want to work out lose then win. So along this branch, we times together these numbers, which would be 0.6 times 0.4. And hopefully you can see they're going to be the same numbers because they're just the same numbers switched around. So it'll be the same answer. So 0.4 times 0.6 gives us 0.24, and that would be the same for both those two options. And now, like I said, because either one of them can happen, we then want to add these two numbers together, which then gives us a grand total of 0.48. That's the odds of her winning exactly one game. So just to recap, you times along the branches, and then once you've got more than one answer at the end, you will then always add those together. Okay? Just do one more tree diagram. So, in a bag there are 5 marbles, 2 blue and 3 black. I take 2 marbles. What's the odds of getting 2 marbles of the same colour? So let's work it out. We're going to model this as 2 separate picks. So I'm going to have a first pick and then a second pick. So for the first pick, I can either take a blue marble or I can take a black marble. Okay? And the odds of me taking a blue marble, we can work out using this formula here. There are 2 blue marbles and there are 5 marbles altogether. So the odds of getting a blue marble is 2 out of 5. And the same idea, black marble will be 3 out of 5. So there's 3 blacks and 5 marbles altogether. Now things change slightly. Okay? For this second pick, I picked a blue marble first. That means that blue marble has gone. It's no longer in the bag. So if I look at my bag now, there'll only be 4 marbles left, of which one of them will be blue and 3 of them will be black. So the odds of getting another blue marble will now be 1 out of 4. 1 blue marble, 4 marbles altogether. And the odds of getting a black will be 3 out of 4. 3 black, 4 marbles altogether. And we're going to have the same kind of thing if you pick a black first. But this time these numbers are going to change. So let's look at that one as well. If I've picked a black first, I can either get blue or black again. But 1 black has already gone. So now there's 4 marbles left in my bag, of which 2 are blue and 2 are black. So that means the odds of getting a blue marble will be 2 out of 4, and it'll be the same for getting a black marble. So now we've got our probabilities. Let's read the question. What are the odds of getting 2 marbles of the same colour? So that can happen one of 2 different ways. We can either get blue then a blue, or we can get a black then a black. And same as before, we're going to work both these out, and then we're going to add together those 2 numbers. So blue then a blue, we're going to do 2/5 times a quarter. Black then a black, we're going to do 3/5 times by 2/4. And again, you have a calculator to work this out, and it's absolutely fine here if you want to work in decimals. You basically have a choice whether to work in decimals or fractions. Of course, it's different if it's non-calculator. So 2/5 times a quarter, that was up here. That's probability of 0.1. I do the same thing here. I want 3/5 times 2/4. That gives me 0.3. So again, these are my 2 options. So we always times along the branches, and then we get more than one number or more than one way to satisfy the question. We then add these numbers together. So the odds of getting 2 marbles of the same colour is going to be 0.4. Okay, and that's it. The key rule of all these tree diagrams is read the question really careful, and you basically want to work out, is the thing being replaced or is it not being replaced? If something's being replaced, that means probability is staying the same. It's like our first example, when the odds of winning never changed. If something is not replaced, that then means in this question that chocolate has gone, so there are less chocolates left, and therefore it's like this example here where the number of marbles changed, and so the probabilities. So the key thing to get this right is read that piece of information, and that'll tell you everything you need to know, whether or not they're replaced or not replaced. Okay, thanks for listening and good luck.